Pluck a string on an electric guitar with the amplifier off, and you hear almost nothing. A thin, dry twang. Yet plug it in, and that same string can fill a stadium. Nothing touches the string, no microphone listens to the air, so how does a vibrating piece of steel become a wall of sound? The answer hides under the strings, in a small bar wrapped in copper. Let us slice the guitar open and watch electricity appear from pure motion. Start with the string itself. On an electric guitar, it is made of steel, and steel is magnetic. That detail is everything. A nylon string, or a soft brass one, would stay silent here. Run your eye down the neck, and every string crosses over a small metal block set into the body. The string never touches it. It floats a few millimeters above, held tight at both ends, waiting. That tiny gap of air is where the whole trick happens. That metal block is the pickup. Open it, and you find two simple parts. First, a magnet, or a row of 6 small magnetic posts, one sitting under each string. Second, a coil of copper wire wound around them, often 5,000 to 10,000 turns of hair-thin wire. The magnet sets up an invisible field that reaches up and surrounds the string. The coil sits quietly inside that field, doing nothing yet, like a net waiting for the water to move. Here is the clever part. The magnet does not just sit below the string. Its field soaks into the steel and magnetizes the small section of string right above it. For as long as it hangs there, that piece of string becomes a tiny magnet of its own. Hold the string perfectly still, and nothing changes. The field is steady. The coil feels a constant pull and reports nothing at all. Electricity only cares about change, so we have to make the little magnet move. So pluck it. The string springs into motion, swinging back and forth hundreds of times each second. The lowest string sways around 80 times a second, a high string, many hundreds. Because that stretch of steel is now magnetized, its own little magnetic field swings with it, sweeping toward the coil and away again, over and over. The steady field has become a moving field. And a moving magnetic field is exactly the thing a coil of wire is built to notice. This is the law that makes it work, discovered by Michael Faraday. When the magnetic field through a coil changes, it pushes the electrons in the wire, creating a voltage. Move the magnet faster or swing it wider, and the push grows. The coil is not powered. No battery feeds it. The motion of the magnetized string alone drives the electrons back and forth, with thousands of turns adding their tiny pushes into one clean signal. Motion goes in. Electricity comes out. And the signal is not random noise. The voltage rises and falls in perfect step with the string. When the string swings one way, the voltage climbs. When it swings back, the voltage drops. Draw it on a screen, and you see the exact shape of the string's motion traced in electricity. The pickup has made a faithful copy of the vibration, written in volts instead of air. It is a picture of the sound, formed before there is any sound at all. That electrical copy carries two facts. The first is how fast the voltage wiggles, which is the pitch. A string vibrating 400 times a second makes a voltage that wiggles 400 times a second, and your ear will call it a certain note. The second fact is how big the wiggle is. Pluck softly, and the swing is small. Dig in hard, and it grows. Big wiggle, loud sound. The pickup captures both faithfully at the very same time. Where the pickup sits changes its voice. Near the bridge, the string barely moves, so the pickup hears a tight, bright, cutting tone. Near the neck, the string swings in a wide arc, and the same string sounds round and warm. This is why many guitars carry 2 or 3 pickups. Flip a switch, and you choose which slice of the string's motion to listen to. Same string, same note, yet a completely different color, set only by position. There is one flaw. A single coil is also a tiny antenna, and the electrical wiring in your walls hums at 60 cycles a second. The coil picks that up as an annoying buzz. The fix is elegant. Place 2 coils side by side, wound in opposite directions, with the magnets flipped. The outside hum hits both and cancels out. The string's signal does not. The buzz vanishes, the note stays. That trick is called a humbucker because it bucks the hum. Now the small signal leaves the guitar. It is faint, only thousandths of a volt, so it travels down a shielded cable to an amplifier. The amplifier does one job. It makes a larger exact copy of that wiggle, pouring in power drawn from the wall. That stronger signal drives a speaker, pushing a paper cone back and forth in the same pattern the string first traced. The cone shoves the air, and only now, at the very end, is there real sound. So follow the whole chain. A steel string crosses a magnet, and the magnet turns that bit of string into a small magnet. You pluck it, and the magnetized string swings through a copper coil. The moving field induces a wiggling voltage, an electrical copy of the motion. Pickup position colors it. A second coil cancels the hum. The cable carries it to the amplifier feeds the speaker, and the speaker moves the air. Steel, magnet, coil, current, sound. No microphone, no moving air, not until the final step. Just a magnet, a coil, and a law about moving fields that Faraday wrote down 2 centuries ago. The next time a guitar roars, remember it began as a silent steel string, trembling a few millimeters above a magnet. That is the whole secret, sliced open. Quiet motion, turned into electricity, turned at last into sound.